guys, so we're going to talk about transformations of quadratics. So the first thing we're going to do, some of these are a little review. Some of these are kind of new. So I need everyone to open a new document for me. So one of you is my presenter. Open a new document for me. Do you want to save? No. And add a graphs page. So I want everyone to start with the parent function x squared. All right, you ready? Is that you? Thank you, ma'am. All right, so I want everyone to start with x squared. So I want you to type in x squared, enter. Hey, we've got our parent function, right? So that's where we're going to go from. So I want everyone to push tab. All right, and we're going to graph a times x squared where a is bigger than 1. So I need a number bigger than 1. 6. Go for it. Some of you said 2. So I want you to graph a number bigger than 1. So push tab, and I need a number bigger than 1. Any number bigger than 1. All right. 17, all right, and then x squared. All right. And what happens? Enter. What happened? It got narrower. So we're going to call this a vertical stretch. Think about a marshmallow. If I hold it on the top and bottom and I pull on it, what's going to happen? It's going to get long and narrow, right? So we're going to call this a vertical stretch. Vertical stretch. All right, so if you would, please push tab. We're going to go up and we're going to change that 17. Push tab. Go up. We're just going to edit that 17. So go back and delete 17. And well, this one, instead of a negative, I want it to be a positive number that's smaller than 1. 0 is not positive. 0 is neutral. Nope. 0.5, that's a good one. So let's put 0.5. And before you hit enter, promise, that's okay. We'll guess on the next one. So what happened this time? It got wider. So again, think of that marshmallow. Think of that marshmallow. If I have a marshmallow and I hold it in my hand and I push on the top, what's going to happen to it? It's going to squeeze out of the sides, right? It's going to get wider. So we're going to call this a vertical compression. All right. Thank you, promise. I'm going to choose someone else. Let's see here. Let's choose... Oh, who's here? You should be graphing. Oh, this is a good one. There we go. Sorry, I didn't want to let go. All right, so I want everyone hit enter so that you're not in the graph line anymore. And we're all going to start from the beginning. I want you to push delete, delete, delete. Yes, delete everything. We're going to start with a fresh screen. Delete, delete, delete. Push delete, delete, delete. Yes, there you go. So we're going to start with the fresh screen. So I want everyone, push tab. We're going to start again with that parent function, x squared. Start again with the parent function, x squared. Go, 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 go. All right. And I want to graph negative x squared. So push tab. And what's a number? What's a negative number? Just negative 1? Negative 5? Negative 6? So any negative number. Enter. And what happened? It's upside down. It flipped. It flipped, so we're going to call this a reflection in the x-axis. A reflection in the x-axis. Yes? All right. So push tab. Go up. We're going to change that now. We're gonna change it up a little bit. So now instead of negative x squared, so go ahead and backspace. Let's clear out this line. So, and let's do open parentheses. So open parentheses, and then I want a b value bigger than 1. 2. All right. So 2x close parentheses squared. Ooh, it got narrower. So this one, again, I want you to think of the marshmallow, but think of it this way. So my hands are like the parentheses, right? Look, look, look. Y'all see my hands? Parentheses. You see my hands? They're parentheses. She did 2x squared. If my marshmallow is between my hands and I push, what's going to happen? It's gonna move up and get thinner, right? So we're going to call this a horizontal compression. Thank you for your service, Faith. I want to choose someone else. See here. Take everybody. You're scared. Let's see. Ah! Who's this with a crazy screen? That's you again? Okay. I'll choose someone else. You already went. I already picked on you today. See? Ooh, a blank screen. I like that. It's like a blank slate. All right, so let's all start with that blank screen again. So delete, delete, delete. All right, so my new person, we're starting from the beginning. Let's go ahead and start again with that x squared, the parent function. X squared, enter. We've got our parent function. So then push tab, and this time we're going to choose a b value less than 1 but bigger than 0. 0.5. So let's do open parentheses 0.5 x close parentheses squared, enter. Ooh, so what happened? It got fatter. So think of it this way. What if, Armando, can you take your headphones out? Thank you, gentlemen. What if I took a hold of that marshmallow by its sides and pulled? What happens? It's a horizontal. It's gonna get wider. So that's a horizontal stretch. We're gonna stretch it on out. A horizontal stretch. A horizontal stretch. All right. So let's go up and let's change that 0.5 to a negative x squared. So go ahead and push tab. We're going to change that to negative x squared. So you might want to delete that times. There you go. Oh, what happened? It stayed the same. So we're going to do something kind of crazy. I want you to push tab. I want you to go up to our parent function. We're going to change it just a little bit. So go up to F1. And we're going to change that to, let's do in parentheses, x plus 2 in parentheses. So open parentheses, x plus 2 close parentheses, squared. All right, enter. So that moved my original 2 units to the left, yes? Let's do the same thing with the red function. So push tab, go up, and we're going to change that to negative x plus 2. Let's see, does it stay on top? Oh, no, it moved to the other side, right? So what this is it's a reflection in the y-axis. A reflection in the y-axis. Beautiful. Very nice. All right. The last rules earlier this morning, everyone's told us, oh, we don't need to check those in the calculator. We remember those from vertex form. Do y'all want to check them, or do y'all feel pretty comfortable with those? Check them? All right, let's check them. Let's do it. Why not? It'll take but a second. So I'm going to pick a new presenter. Let's see, let's see. Ooh. I haven't picked you yet, have I? Hey, all right. So push tab. Let's graph x squared. All right. Beautiful. And now let's graph x plus some number. So open parentheses. You want to start with parentheses. Ooh, nice edit. There we go. X plus, what do you think? 4. 4 looks good. 4, close parentheses, squared. So what happened? X plus 4 squared. So what happened from blue to red? Did it move left or right? Left. So we're going to say x plus c. Oh, I need my pen. There we go. Left c units. So what do you think is going to happen when I have x minus 4? It's going to move to the right c units. So the next one's going to be right. There we go. All right. What about x squared plus d? So if you could we edit that one? So go up. And instead of the plus 4 on the inside, can we put the plus 4 on the outside? Beautiful. Very good. That was a good choice of numbers there. 4. Ooh, so what happened? It moved up 4 units. So here the rule is up d units. So what do you think minus d is going to do? We're going to go down d units. That was beautiful. Thank you. All right, so now we're going to use these rules to do a little bit of practice. So I'm going to do a couple of these problems with you. You ready? You ready? All right, hold on. So I'm going to choose a new presenter. Y'all are doing such a fantastic job presenting. Thank you very much. Let's see. Who do I want? Who do I want? Who do I want? Oop, not logged in. Ooh. You're ready to have a new graph. No, I haven't. Have I? Really? No. It'll be okay to go again. So go ahead and push menu so that you have a graphs page. All right, let's take a look at number 1. You ready? So first, let's read the directions. Okay. You okay? Okay. I'll get you a copy of the notes in just a minute. So number 1, the directions say graph the f of x function using a dotted line, and then graph the g of x function using a solid line, and then we're going to describe the transformation. You ready? So number 1, we've got f of x is equal to x squared, so let's graph x squared first. All right, enter. Beautiful, so let's go ahead and graph that. So that's an average parabola right there in the middle, right? So let's sketch that graph real quick. So the first one's going to be a dotted line. All right, so next, let's graph that x squared minus 2. Let's see. So push tab. We got x squared minus 2. Oh, so what happened? We went down. How far down? 2. We moved 2 units down. So I'm going to go 1, 2. I'm going to sketch this graph using a solid line or solid curve. And then my description, we're going to say we went down 2 units. The first function is always going to be a dotted line. So the first function is not always a parent function. I'm going to show you an example of that right now. So you guys are going to do 2 because that's another one just like this. So let's take a look at the back. Let's flip it on over to the back. Let's see. 3 is pretty straightforward. 4 is pretty straightforward. No, you guys are going to try 6. 6 is a good one. Let's do... we can do 5. Let's take a look at 5. So, I'll get a new presenter. Thank you, dear. You did a fantastic job presenting. All right. New class. New presenter. Yeah, that mixes them up every time. All right. So let's graph the first one. Oh, see, the first one's not the parent function. It's x squared minus 1 is our f of x. Now see how it says x squared minus 1, so let's graph x squared minus 1 first. So that's where my function starts. We're going to go down 1 unit. Oh, I need my pen. There we go. Down 1 unit. I'm going to graph a dotted curve. All right, so now let's graph g of x. G of x is 1/2 x squared minus 3. So tab. Oh, move your cursor. My presenter, move your cursor off. There you go. Now push tab. There we go. So open parentheses. 1/2 x. Oh, nice use of a fraction. Close parentheses squared. Minus 3. Whoa, what happened? It went down how many units? 2 from the original, right? So it went down 2 units. And what happened? It got wider. So I'm going to draw a wider parabola that translated down 2 units. So I'm going to say my description is down 2 units. And this is where we have to pay attention to the rules. So if it got wider, it's either a vertical compression or a horizontal stretch. So where is that 1/2? Is it inside or outside of my parentheses? Inside, right? That 1/2, bless you. That 1/2 is inside the parentheses. So that's a horizontal stretch, is what we're going to call it. Horizontal stretch. Bless you. All right, I want you guys to do the other 4 problems. I want you to do the other 4 problems. Use your calculator to graph if you need that visual, but I do want you to sketch them also, okay? You can work in your groups. I'm going to come around, answer questions, and make sure we're doing all right.